How's it going, guys? It's going off grid, and today we got my PowerBright inverter, 12 volts. I've had this forever, and one day at work I was hooking it up because I was building a house completely off grid, and I had a bunch more guys coming to help me that day, and we were using much more power than normal, and we just needed more power. My work trailer didn't have quite enough. The one compressor we were running wasn't enough, so I needed two. So I hooked this up to my Jeep quickly. I was going to run my Jeep for about an hour just for the quick little bit that I needed the extra power for. And I was in a rush. And what did I do? I hooked it up backwards. I hooked up the negative to the positive and the positive to the negative. And immediately something blew up inside, sparks. And we're going to see what the heck that was and then see if I can repair it. And if we're lucky, it'll just be the fuses, because when you hook these things up backwards, the MOSFETs act like a complete short, and either the MOSFETs, the input MOSFETs, they either blow up or the fuses blow. And hopefully this is fused properly, and the fuses just went. Even if it's fused properly, there's still a high chance that the input MOSFETs are blown. But let's see how this goes. Okay, so we got the lid off, and by immediately looking at the input FETs there and these two here, it doesn't look bad. So there's a chance that the FETs are not blown, and that all of these fuses, there are 40 fuses, there's so many of them, and they're soldered to the board, which I hate it when inverter manufacturers solder their fuses to the board. It's so annoying, because, like, honest mistake, if it was just the fuses, boop, 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 pop them out, pop them in, no big deal. But now I got to take this whole thing apart. This whole board's going to come out for me to get those fuses out. It looks like this is some. It kind of looks like it's in between the high voltage DC and the switching AC side. They got some fuses. I haven't really looked at this very well, but just in the placement on the board, that's kind of what it looks like, which is really cool. But yeah, so I got to get this thing apart, get the board off, unhook everything, flip it over, unsolder those fuses, and resolder some new fuses in. Let's get to it. Well, actually, I did this off camera. I checked all the MOSFETs, and all of them are showing good values. They are not blown. They're showing, like, on the ohm setting, I think they're showing around 500, around that area. If it's anywhere it's between like 390 and 500, your MOSFETs are usually pretty good. And that those values are normally actually the resistors beside the MOSFETs. You're just making sure that there's no shorts in the MOSFETs, and they all read the same, so we're looking pretty good. So I am 90% sure it is just the fuses. So we're going to take this apart and replace them. Great, we're back. Now, for those that hear the generator in the background and don't like it, I got a 9,000 watt Champion generator that I almost never run. And I'm running it just because the gas goes bad in it, and I got to run it. I run one tank through the year just to keep it good. So that's why it's running. I do not need to run it. Anyways, we're just taking these screws out here on all four corners, and I hope that this thing just comes right out. Unless, let's see here, do we have screws on the bottom side holding the heat? Yeah, look, we got 4 screws and 4 more screws there on the heat sink, and then this whole board should come right out. I'm just going to flip it up because this is all attached, and it's actually soldered to the board, which, why? I don't know why. But anyways, it's soldered to the board instead of having quick disconnects. Like, even Reliable's inverters, everything's quick disconnect. Reliable's inverters have replaceable fuses. Everything's just quick disconnect. I don't like this design. They're just being cheap. But other than that, I still really like this inverter. As long as it doesn't, and nothing happens to it, it works fine. Anyways, let's keep going. One more thing. I'm going to let you guys in on a little secret. This is my favorite modification to do to all inverters that I get. I open it up, and I find this dang little beeper, and I just go like this. That's it. Boom. Modification done. That's one of the best mods you can do to your inverter, at least in my opinion. Alright, so we got the inverter opened up, and it is kind of dirty. Yeah, just a little dirty. Now, this is fastened to the bottom case here, but there's no like actual heatsink compound, so I might put some on there if I can find some. And on top of that, everything looks a little bit grubby, like nothing got cleaned after they soldered everything on here. But or this could have been, I did buy this off of Amazon, so the buyer could have used this before me. They could have had it in a wet area, but this is where I got to be soldering here. I got to replace all these fuses, so I need a big soldering iron, something that, with a lot of thermal mass. Let's see, is it getting warm yet? Yep, getting warm. We're using my good old power box I made. Just a what is this? 48 volt power supply. This is a buck step down converter, and then that goes into a 24 volt battery bank. It's approximately, there's 4 batteries in here at 800 watt hours, so what's that, 3200 watt hours, so 3.2 kilowatts with a power jack. I believe this is a 3000 watt inverter, but it's not. It can, if you consider this a 1000 to 1500 watt max inverter, it's okay. Don't recommend this inverter really, but as you can see, it's on, it's working fine. I will say, with the derating it has, I've overloaded it a million times and it hasn't blown up, but it can barely do 1000 watts with a clean sine wave. But it works great for a soldering iron. I think this is 150 watts or 200 watts, or it says 200 watts right there. Oh, at 220 volts. Oh, I wonder what it is at. It's smoking, so it's getting hot. I wonder what it is at 120. It's probably like 80 watts then. Oh well, we'll see. It's smoking, so that's not very good. Hopefully it's not going to burn itself out. Anyways, I'll let you know when I get all these replaced. See if I can find myself some replacement fuses actually. Alright, so it turns out I was right. That is a 200 watt soldering iron at 240 volts. Or 220 volts, it says right there. Well, that's not what it said when I bought it. It says 120 volts at 200 watts. So if this is 200 watts at 220, at 120 volts, it's not going to be 100 watts like you would think. Heating elements don't work that way. It's probably more like a 60 watt or something like that. This thing's been plugged in forever, and it's taking forever to heat up. So I've got up my old. This one, the tip's just running out. Like I keep grinding it down, and it's just having a hard time, that's all. This one, this heats up almost immediately. That one keeps smoking and stuff from the inside, so I don't know what the heck's going on with it. It might just be oils burning off, but it's still smoking. I don't know if you can see it. This one heats up within 2 minutes. This one's, I've already given it 15 minutes. It still won't melt any solder, so will not be recommending that brand. Okay, so this is such a pain in the butt trying to get the new ones in. I got a couple in, but it's taking forever and I'm just getting impatient. I'm going to completely bridge this whole thing with solder, and from now on I will not be using this thing without a fuse on the outside. So this will be, I'm just going to write right on the top, fuse required, because this is insanely ridiculous. I know I could just clean up all this, just get rid of the solder, push them through, but I mean, I gotta stinking unhook all this stuff. I don't know. I'd rather just bridge that over and then just put an external like 250, 300 amp fuse on it. I have them, so might as well just do that. Alright, so we got it bridged, as you can see from that massive glob of solder sticking up right there. We bridged everything across. This now will not be used without a fuse or without a limited current supply coming in, such as this power supply. And yeah, we're just, all I got left to do is to screw down these 2 heat sinks, and then once that's done, hook up these 2 terminals, hook the fans back up, and then give her a try. Alright, so we got the meter set for 15.68 volts. We got the inverter here. Just going to connect the positive here. Connect the negative. Now, we're going to just turn it on, see if there's a dead short. I have it limited to 5 amps. It showed a peak just for a second. Now, oh, look at that. It's on. I left the switch on. Now, does it work? And it works. Look at that. Well, good job, PowerBright, for making at least it's fused right so that when you hook it up backwards, the MOSFETs don't blow before the fusing does. That's really nice. I'm really happy about that. So I got a 12-volt inverter again. This inverter actually works really good with that blue battery in the last video, because this inverter can accept up to 17 volts input, which is really nice. I really like that. You can get the same inverter or similar from Reliable. If you tell them you want an inverter that can accept up to that voltage, they will build one. But anyways, hope you guys enjoyed the video. Thanks for watching. There's my last little bit of solder and stuff from removing all these fuses. Like, some of the fuses didn't even come out in one piece. Awesome, I'm excited. I got another working inverter. Alright, so I can't end the video here. We gotta test it out. This is a 1500 watt inverter. We got a 1500 watt heater, and we're going to test it out. So what I got going here is my charger's helping at full 20 amps setup. I have 100 amp BMS here. This is approximately 16 volt battery, approximately, so it can do about 1600 watts. Now, that's getting a little bit close to its max, so I got an extra 20 amps coming from the charger to help it. I just got to turn the charger on with my phone, and then I'm going to be ready to start the maximum load test on this thing. Here we go. Okay, so the temperature of this battery was below 0, and I have the BMS release point. It won't let you charge this battery, even though it's lithium ion, and you can charge at below 0. It would not let me charge it, and I was trying to figure out, why can't I charge this thing, and it wouldn't let me turn on the charging option on my phone. So then I went into parameter settings, and I realized that at -5 I had it so it completely shut off charging, and it wouldn't release that state till around 0 Celsius. So I changed that to -10. At -10 it will no longer charge, and at -7 it releases it. So at least I can quickly do this. We have 14 amps going in right now. So we're going to turn this baby on, and I have these snips cut here because this is no longer fused. All I have is the MOSFETs here to blow as fuse, and then I got the MOSFETs on that BMS, same thing. So I have those snips there just in case. Okay, it's on. You can see that this is on, and let's hit the power button. Oh, wrong button, sorry. Here we go, it's on, and it's working. Wow, it's working just fine actually. You know what? Let's get a kilowatt meter on this thing so we can make sure it's working properly. Okay, we got our kilowatt meter here. It's showing it's using 15 watts. Just having it plugged in, that's not very good. Okay, we're gonna turn it on. So it's on. I hear a super high pitched sound coming out of this thing. But it seems to be working now. The high pitched sound has gone away. 1200 watts, 100% power factor, more or less. Okay. Everything seems to be working just fine. Where it's pumping out the heat. Oh yeah, that feels great. It's kind of cold in here. Battery seems to be doing just fine. Putting out the full 20 amps now. Now, I'm wondering if it's coming out of this kilowatt meter, because it wasn't making that high-pitched sound before. It's very interesting. I can barely hear it now, but it's settled at 1200 watts. It seems to be working just fine. I'm actually going to leave this running for a little bit, and I'm going to wait till the fans turn on, make sure everything's working properly, it's not going to blow up. And then I'm actually going to put this in my Jeep as my my 12-volt inverter in for my Jeep. Actually, I think right now I have the Reliable in there, so maybe I won't do that. If I have, I only need one anyways. But this will be a nice backup 12-volt inverter. Okay, fans just turned on. Everything's working as it should. The high-pitched sound went completely away. I don't know what that was really, but it's completely gone now. So everything's working great. I've been running this thing for about 20 minutes now. I'm standing in front of it now because I'm kind of cold. Anyways, everything's working great. I would call this a successful repair, and a nice easy one at that, because all it needed was me to replace the fuses, which I didn't do. I just bridged it, and now I'm going to write right here in permanent marker, fuse required. Anyways, thanks for watching, guys. Hope you enjoyed the video.